Now let's jump to our basic diagram and see what are the elements that make up the cell. Our cells are composed mainly of organic and inorganic compounds. The main organic compounds are the carbohydrates, proteins, lipids, and nucleic acids, DNA and RNA. I will be going into further detail about this in another lesson, and we will find out how the rule of 4 applies in a surprising and magic way in each of these 4 compounds. But what are organic compounds? An organic compound is a chemical compound composed of a main carbon backbone, carbons connected to each other in a chain-like structure, to which are connected many other atoms and molecules. But why carbon? Carbon is a sexy element. It is sexy because it has 6 electrons, 6 electrons, 4 of which are valence electrons. The reason carbon bonds so readily and in such variety is that its second electron shell is half full. 4 out of 8 energy levels are filled, forming easily 4 bonds and making it the perfect ingredient of life. I told you that number 4 was the number of life itself. Also, carbon loves to bond, and it is very happy to share electrons with almost any reasonably friendly nearby atom, even other carbons. One thing I want you to remember from organic chemistry, that carbon is a whore that gave birth to the life. What about inorganic compounds? Inorganic compounds are chemical substances which are simply not organic compounds. There are many definitions and criteria for them, but they usually don't contain any carbon backbone. Some good examples are water, most abundant, the oxygen we breathe in, the carbon dioxide we breathe out, and the hydrochloric acid in the stomach, etc. So our cells are composed of molecules, which in turn are made up of atoms. So our body is made up with most of the elements in our periodic table. The elements that make up our body are composed into 4 categories. First, the 4 organic basic elements, which are the oxygen we breathe, the carbon found in the diamond, the hydrogen found in the stars of our universe, and finally the nitrogen, which is the most common gas in the air and also is part of our DNA and proteins. Since our body is 60 to 70% water, which has the chemical formula H2O, is no fun in telling that oxygen and hydrogen are in our top 4 list. Then we have the 7 quantity elements. First is the calcium and phosphorus in our bones, then the potassium, which is found mostly inside our cells. In fact, our cells are a bag of potassium or of bananas, since bananas are a good source of potassium. Then we have the sulfur, found mainly in proteins, the sodium and chlorine, found mostly outside the cell, that makes up the fluid outside cells salty, since sodium chloride is the chemical formula of salt. So our cells are basically floating in salty water, just like a submarine floating in the sea. And finally we have the magnesium, which, like potassium, is also found inside the cell and is part of proteins called enzymes, which are like cell workers, since they make the metabolic reactions happen and make them happen faster. They are just like mounting and unmounting molecules with each other. Then there are the essential trace elements, like the iron in our blood, the iodine essential for the production of the thyroid hormones, and some other elements. The last are elements with possible structural and functional role in mammals. Since these are not very important, I'm not going into further detail, I'll just write them down. So our life is chemistry. Everything is chemistry. Our actions and thoughts, our ideas, our beliefs, our feelings and emotions, our perception and reality. Everything depends in the dynamic interaction between these energetic and electrical particles. But also don't forget that everything around us is made of atoms, every living or non-living thing, even our Earth and other planets. The stars and the whole universe is a giant mixture of atoms. But where do the atoms come from? Every atom in our body is billions of years old. Hydrogen, the most common element in the universe and the major feature of your body, was produced in the Big Bang 13.7 billion years ago. This means that the components of our body are truly ancient. We are stardust. Just for completeness, I must say that the atom is further subdivided into tiny particles, but I'm not going any further into the quantum world. I would like to end this lesson with a question. You saw from the image that the atom is almost 99% an empty space. So all the atoms in the universe are almost entirely empty spaces. Why does anything feel so solid? But right now this is none of our business. But if you are curious, I will post a link in the description explaining the reason why. If you really liked these videos, you can subscribe to my channel or follow me on social media.